Hi there. In the previous video, I talked about the hardware configuration of my robot, which basically has a Realsense D435 RGBD sensor, a Raspberry Pi 4, and an Arduino Mega to control the motors. In this video, I want to talk about how to use ROS's RTABMAP package to implement SLAM, which is basically simultaneous localization and mapping. So I'm controlling or I'm accessing the robot's Raspberry Pi using TeamViewer. And so let's look at the launch file over here for ROS. So the first thing is we're just launching the camera node, which is provided by Realsense. And the next thing that we're doing is we're launching a nodelet manager, and we're launching a node that is going to sync the RGB images with the depth images before broadcasting them over the network. And that will allow us to synchronize the RGB images with the depth images when we are performing the SLAM calculations. We are also launching the ROS serial node, and we are broadcasting the transform from the camera link to the base link, which was written for this robot. And over here, the first thing that we want to do is launch this file, but first we want to set up the ROS master URI and the ROS IP for the robot, and we'll do the same for the remote laptop. And in order to look at the IP address, we just have to run IPA, and over here we see the IP address that we want, and we are just going to say ROS master. We're going to set this to the IP over here, followed by a colon 11311. And we're going to do the same thing for the ROS IP. So we're going to say export ROS IP equals, and then we can just copy that in, and that should be good. All right, now we can go ahead and launch our launch file, which is the synced RGBD launch file, and that's going to open the camera node as well as the other nodes that I talked about. Now on the remote computer, we want to do the same thing. We want to set up the ROS master URI. So we will first export the ROS master URI, which is supposed to be the same as the robot's. And next we will set up this laptop's ROS IP so that when we send teleop commands, the robot can listen to them. And we just need this address over here. So we're going to say export ROS IP equals, and then the IP. All right, so now we should be able to look at the topics. So ROS topic list, and we can see all of the topics being published over here, the camera topics and the command velocity topics, which we are going to use for teleop. So to have a look at the launch file that we are going to launch on the remote computer, we are just going to launch the RTABMAP's launch file, where we're going to subscribe to the RGBD topic. We're going to specify what the topic is. We're going to set the frame ID. We're going to set approximate to false. Localization is false. We're going to start it up with false localization set to false because we want to map it. We're going to use the compressed topics. We are not going to use the RViz visualization tool. We'll just use RTABMAP's proprietary visualization tool, and we will delete the database on startup initially, but when we are localizing, we won't delete it. And finally, we will launch the teleop twist keyboard node. So let's go ahead and launch the file that I just showed you, and we're going to delete the database on start. So it's going to go over everything, and now we can see the topics over here in this visualization tool that comes with RTABMAP. And we can start mapping. So I'm going to fast forward the mapping process, but you should be able to see the robot move as well. Alright, so we've successfully managed to map out my entire room. You can also see the 3D cloud over here. I've shared a link in the description to my GitHub repo where you can find all the launch files as well as the Arduino sketch that I've used to control the robot through teleop. And that's basically going to be it. Thank you for watching.